So could you characterize your business line? I mean, what rough percentage are you working with unmanned systems versus manned systems versus missiles and other business lines?
So our business is, we've been involved with unmanned systems since our inception. And missiles and precision guided munitions is always a challenging market because of the high vibration and temperature dynamics. So for MIMS, it's an especially challenging market. But we've been on missiles since about 2012. But we've been on unmanned systems since then. Fixed wing, unmanned vehicles. Our largest production unmanned vehicle is the Sheeple Camcopter. We provide an IMU for backup flight control, have for probably about almost 300 systems. But we also have done other applications, fixed wing and things both military and commercial.
Okay, so you mentioned that you're primarily a MIMS-based IMU technology. Can you compare and contrast the advantages between MIMS and other types of technology, laser ring gyros and whatnot?
We're silicon-based MIMS. Number one advantage, of course, is cost, right? So silicon-based MIMS are used in automotive, in your cell phone, things of that nature. Ours are a much higher performance grade than that. Size, weight, power, the traditional SWaP-C, and cost are all the advantages that we can do in MIMS, so they're much smaller. But they're now, from a noise perspective, coming up against the tactical grade ring laser gyros and fiber optic gyros, or the optic-based systems. But our challenge still is bias over temperature. The optic-based, they're still excellent. Really no effect over temperature. And so that's where our challenge is, but we continue to push that. I think a lot of people ask about, are you ever going to get to inertial grade? In the gyros, I think there's a long way ahead in that, and maybe never. But in accelerometers, other competitors as well are moving in that on the accelerometer side.
But you mentioned how challenging it was to use your products in missiles due to the high vibration, high Gs and all that. Are there any specific challenges that you really worry about when you're designing for unmanned systems in particular?
So unmanned systems are different, and it really depends. Anything from the smaller market where we don't compete, the very commercial consumer market. Really we're tactical grade and mid-altitude long endurance. That's really kind of our sweet spot for applications. And so for us, of course, low power, small size, but for us, we've got to be able to perform over the long duration application. And so bias over temperature. Vibration is not as much as you might think. Certainly missiles and precision guided munitions have a much higher vibration spectrum, but the bias over temperature is still always a technical challenge for us when we're using silicon-based MIM.
Don't you find yourself dealing with a really messy environment on board unmanned systems where you get a lot of RF interference and all that? Is that a concern for you?
So all of those things, acoustic interference, vibration, shock, all those type of things are always important. Temperature, so we always have to design that. We've designed a very robust system. Most of our experience in our previous lives was very high dynamic military applications, so we're very accustomed to that. But electromagnetic interference is always an issue as well, and so we really design our system to protect against that. For example, using mil-spec connectors and things like that, so there's no penetration of the radio waves and that type of application. We've got to perform in all environments. We design a commercial off-the-shelf COTS device that can also be used for commercial applications, but also very rugged military applications, and provide that cost savings, to the warfighter and things of that nature.